Hello, welcome to Sigma Made Simple. I'm going to show you a tool that's often overlooked, which can help you improve any process very quickly. We're going to start with a histogram. A histogram basically puts a data set into buckets, where the y-axis is the number of times that data is in that bucket. There are 6 buckets in a histogram based on standard deviation. In the middle of the histogram will be the mean, or the average, of the data. And if the data is normal, it'll also be the median. On each side will be one standard deviation from the mean for each bucket. So each bucket represents about 34.1% of the data in that sample set. Combined, these two buckets, or these standard deviation on each side of the mean, will have about 64.2% of your data. So between 1 and 2 standard deviations on each side of the mean is a bucket having 13.6% of the data. These 4 buckets have 95% of the data in your data set. Between 2 and 3 standard deviations are buckets that have 2.1% of the data in each bucket. Between 3 standard deviations below to 3 standard deviations above the mean is 99.7% of the data. That's important to note that 3 standard deviations below the mean is also referred to as your lower control limit, or your LCL. 3 standard deviations above the mean is the upper control limit, or the UCL. While not all histograms are perfectly shaped like this one, there are probabilities of data being in the same bucket of the standard deviations. This is where a control chart, like an individual's chart or an eye chart, comes in handy. Using basic principles of probability in each bucket, you can detect if a change in the process has caused a change in your data at 95% confidence level. 95% confidence level is a basic premise for statistical analysis. It's your basic bar that you must pass. So we're going to spin this to the side, and then we're going to overlay it on to an individual's chart. So an individual's chart, or eye chart, is just a histogram where the x-axis is a unit of time and the y-axis is the data. See, time on the bottom, older data on the left, newer data on the right, and this is the actual number. So if it was 200, it would go on this line. So an eye chart is used to tell the difference in what we call normal variation versus special cause variation. For normal variation, changes in the data are nothing to be worried about and are expected to occur. Make a change to your process and look for one of the following special cause variation or attributable cause variation in the next slides. So here, if you have one data point more than 3 standard deviations from the mean, this is significant at 95% confidence level. If the change in the data is desired, keep the new process. If not, go back to the original process. You will recalculate the mean and standard deviation after the minimum sample size has been achieved. More on calculating your minimum sample size will be discussed in a different video that will be titled Sample Size Determination. For now, we just want to understand what we're looking for. Here, 2 of 3 consecutive data points are more than 2 standard deviations from the mean on the same side. This is special cause variation and is significant at 95% confidence level. If the change in the data is desired, keep the new process. If not, go back to the original. Again, you'll wait to get the minimum sample size to recalculate your mean and standard deviation. You just keep tracking your change. So here, there are 4 of 5 consecutive data points that are more than 1 standard deviation from the mean on the same side. This is also special cause variation and is significant at 95% confidence level. If the change in the data is desired, keep the new process. If not, go back to the original. You'll again recalculate the mean and standard deviation after minimum sample size has been achieved. So here we have 8 consecutive data points above the mean on the same side. This is special cause variation and is significant at 95% confidence level. If the change in the data is desired, keep the new process. If not, go back to the original. So in all of these special cause variation, you're going to recalculate the mean and standard deviation after the minimum sample size has been achieved. Again, there'll be a video explaining how to determine the minimum sample size. It is based off of your standard deviation. There are other statistically significant data trends when using control charts, especially for eye charts, and you should get to know them, but these are going to be the ones that I've shown you are the ones that are probably the most popular and have the most meaning. So, what do you need to do? Well, you must have a documented process under revision control. It's very important to know what you need to do and when you need to do it. Without this and without following it to the letter, you will increase your standard deviation and make changes more difficult to detect. You should be able to detect a change in the data and no more than 8 data after the process changes. Document the dates you make any changes to the process and make one change at a time. This prevents you from making an unnecessary change that could cost you money. Remember, your data is an output from a process. Your changes in the process may have an impact on your data. This is detected by looking for special causes described in the previous slides on your eye chart. You can use an eye chart to verify a change to the process and that it had the desired impact on your data. So when your data is normal, has a constant trend, and has a mono frequency, that means you have a stable process and you have usable data as long as you go through and clean it up. Next week's video is going to explain why that data passes a normality test and is not always usable due to changing trend or multi-frequency. These things can also cause you to pass a normality test when you have non-normal data, and they can also cause you to fail a normality test. So next week we're going to be talking about that, so make sure you watch. And it's going to show you how to account for the trends, frequencies, and then also how to clean up your data. So if you want to learn more about control charts or Six Sigma, especially eye charts, these 2 pocket guides are excellent sources. You can read them carefully, just read them carefully, but you can learn a lot from them, even not having had any uh, formal training. So these 2 books, coupled with the videos that you're going to see on this channel, could make you a very effective continuous improvement engineer. I've had these pocket guides for decades, and I've gifted them to many people, and everybody really appreciates having them. So you can use an eye chart to verify expected changes in data when a process changes. Combined with documented changes to a stable process that results in normal, constant trending, monofrequency data, you can make changes to your process and verify the improvement in performance. The next video will show you how to identify the data that passes a normality test but is not usable and how to make it usable. If you found the video useful, like it, subscribe to the channel, and share it with somebody else. If you didn't find the video useful, subscribe in the hope that an upcoming video will be. Eventually, we're going to go through projects with Lean Sigma and Six Sigma, as well as the tools needed to support them. Remember, a wise person learns from their mistakes, while a genius learns from the mistakes of others. Until the next video, take care and keep your data clean.